stick to the wall or wondered how lighting forms during a storm? These are examples of electrostatics, the science of electric charges at rest. In this video, we'll explore the fascinating world of static electricity, Coulomb's law, electric fields, and more. Let's dive in. What is electrostatics? First, let's talk about electrostatics. It is the study of electric charges that are not in motion, also known as static electricity. Everything around us is made of atoms which contain positively charged protons and negatively charged electrons. Normally, an object has an equal number of protons and electrons, making it electrically neutral. How do balloons stick to walls? So, how do balloons stick to walls? It's all about charging by friction. When you rub a balloon on your hair or a sweater, electrons are transferred from one object to another. The balloon picks up extra electrons, giving it a negative charge. When you bring the negatively charged balloon close to a neutral wall, it causes the charges in the wall to rearrange. The electrons in the wall are repelled, leaving the surface slightly positive. Since opposite charges attract, the negatively charged balloon sticks to the positively charged wall. This is how a balloon stick on the walls. Coulomb's law. To understand how strong the force is between two charges, we use Coulomb's law. It tells us that the force between two charged objects depends on the amount of charge they have and how far apart they are. The more charge, the stronger the force, and the closer the objects, the greater the attraction or repulsion. As you can see, if you increase the distance between the charges, the force decreases. If you increase the amount of charge, the force becomes stronger. Electric fields and potential. Every charged object creates an electric field around it. This field shows the direction and strength of the force that another charged object would experience if placed nearby. Electric field lines point away from positive charges and toward negative charges. In addition to the electric field, there is also electric potential, which represents the potential energy a charge has in an electric field. The closer a positive charge gets to a negatively charged object, the more potential energy it has, much like a ball rolling down a hill. Some examples, real-time examples for static electricity. One of the most dramatic examples of electricity, that means electrostatics in nature, is lightning. Lightning is essentially a giant electrostatic discharge that occurs when charge builds up in the clouds. During a storm, friction between air particles causes the clouds to become charged, with the negative charges building up at the bottom of the cloud. This creates a strong electric field between the cloud and the ground. When the charge difference becomes too large, it results in a massive discharge of electricity, what we call lightning. This discharge happens in a split second, realizing a huge amount of energy in the form of light, heat, and sound. The thunder you hear after the flash. So, whether it is a balloon sticking to a wall, the force between electric charges, or a powerful lightning strike, electrostatics plays a key role in our world. It's a fascinating part of physics that's all around us. If you enjoyed learning about static electricity and how it saves everyday life, don't forget to like, subscribe,